Algebra 2, state sample question number 7. Algebraically, determine the values of x that satisfy the system of equations below. This might be the easiest state sample question we have. Um, that's saying a lot. A lot of them are very, very challenging. This one's really not too bad. It's very straightforward. So algebraically means they need to see the algebra. This would probably be like a you know probably a part 3 question, a 4-point question on your Regents, which after the scale ends up being about a 6-point question. So it's a great question to get full credit on, and but you do need to show all the work. I am going to show you how to do this in your calculator, but that won't get you full credit. The answer always gets you a point, so if you completely forget how to do this, you could always use your calculator, get the answer, and at least get 1 point. But you're not going to get any. You're going to lose 3 if you don't show the algebra here. That's why they make a specific point of saying algebraically. If they wanted it graphically, they'd provide you with a graph and say graphically. But so how do we do this algebraically? Well, there's 2 ways to do it. One is, well, there's really only one good way to do it, and that is by a form of substitution, and that is that they both equal y. Now, say this wasn't in standard form. Say it was something like y plus 2x equals 1, which I'm surprised it's not. I would first want to get it to look like this. I want them both to be y equals, if possible, or at least, you know, again, it is possible. They don't both have to be solved for a variable, as this is called, to do substitution, but it's helpful if they both are, especially if they're different types of functions, as these are. That this is a degree 1 equation. Means it has a constant first difference. That means it is linear. This has a slope of -2, a y-intercept of 1. And this has a degree 2, which means a quadratic. And not only that, I see a couple of things. I see this negative tells me that it's going to be upside down. It's going to open down. And this negative means a negative slope. So it's going to be an intersection of those type of things. But if you just had one of them solved, you could plug it into the other. But it is helpful when they are both solved for y like this, because if they both equal y, then they could equal each other. So that means that -2x squared plus 3x plus 1 can equal -2x plus 1. Strip the y's away and set them equal to each other. See, the whole point is whenever you're given 2 equations with 2 variables, you have to find a way to combine them into 1 equation with 1 variable. We've also seen questions where we had 3 equations with 3 variables, and we had to go through a long process to get that down. But it's always about figure out a way to combine them, whether with substitution or adding them together or whatever method you can do that will eliminate one of the variables. In this case, we eliminated the y by setting them equal to each other, and we could do that because they both equal y, so they equal each other. Then at this point, we want to solve it, and you can probably guess it's going to require factoring here, so we want to set it equal to 0, so we'll add 2x over here to the like terms, and we'll minus 1 over here to the like terms, and that's going to give us a result of -2x squared plus 5x, and then my 1's cancel out, but I get equals 0. And this is definitely a factorable expression. If it was not factorable, which is possible, it's possible that it's not factorable, I would want to use the quadratic formula that's on your reference sheet. The x equals -b plus or minus square root b squared minus 4ac, or completing the square, but the formula works just fine. But this can be factored. You could have a GCF here. A lot of times people see that squared and they think trinomial factoring, like double parentheses, stuff like that. But when the c term cancels out, as it did here, you just have 2 terms, but they both have an x. So that's all we can really take out is just that x. But that's enough, because what's left is -2x plus 5 equals 0. And that is it for the factoring, and so then what we want to do is set each of them equal to 0. So I set the x equal to 0, and that gives me x equals 0. Done with that. I set the -2x plus 5 equal to 0, and that's going to require me to minus 5 and divide -2, which in the end gives me x equals positive 5 over 2, negative divided by a negative. So those are my answers right there, 0 and 5 over 2. Nothing rejects, nothing, that's it. If they said just solve the system, I would actually then have to plug these x's back in to find their partner y's. Because this isn't a coordinate, this is the x value of two coordinates, of each coordinate. So you could plug them back in to get the y values that go with them. And it's always, you can plug them into either one, but it's usually easier to plug it into the linear. Negative 2 times 0 plus 1 is 1, so the point 0, 1. 5 over 2 times negative 2 is negative 5 plus 1 is 4. So 0, 1 and 5 over 2 comma um, negative 4, I believe. These are the solutions of the points of intersections, but do not do that when they just want the values of x. Don't do extra work. I was just kind of showing you a hypothetical here that if they said solve not specifically x, then we'd want to get the y values that go with them because it's x comma y. But because they just want x's, once you have x, stop. Don't do that extra work, because if you do that extra work wrong, you will lose a point. So make sure you don't go further than what the question asks. But hypothetically, if it wanted more, this is what we would do. And you'd have to show the substitution of plugging them in there and so on and so on. So that's really it for the algebra. Set them equal to each other, set it equal to 0, factor, solve, quadratic formula if it can't be factored. You can do quadratic formula even when it can be factored, you just don't have to. So that's really it. But how would we do it graphically? Graphically, we type them one at a time, both into our y equals, and take a look at the graph. First, it's going to draw my negative 2x plus 1. That's your negative sloped line. And then it's going to draw my frowny face parabola, quadratic. It's frowny face. It's upside down because of the negative in front of that. So here's your graph here. And you could, of course, draw a little sketch of it if you want. But that's the graphic. But how do I still get the solutions from that? Well, you can look at the table, but the table's not great because points like 5 over 2 won't be there. Table only tends to give you whole numbers unless you specifically program it for a decimal, but you don't know that it's going to be 5 over 2 at that point. So really all we can do is use the second trace is calc, and then number 5 is intersect. And that's going to give us this little flashy guy, which I call Toodles from the Mickey Mouse Clubhouse. Reminds me of Toodles. And you move him over to a point of intersection, hit enter, and make sure he's there for both curves in that general area. Hit enter, and then hit enter a third time. It'll give you the point of intersection, 2.5 comma negative 4. That is 5 over 2 comma negative 4. 2.5 is the same thing as 5 over 2. And of course, you could do that same thing with Toodles and that other point of intersection. Now, this one would actually be in the table because it's all whole numbers, but enter, 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 and it tells me 0, 1. So again, they just want the x values here, but that's how you would get the x values and the y values that go with them. So pretty easy compared to the majority of our Algebra 2 sample Regents questions, but an important one. It's got some good algebra concepts in here of setting equal, a little bit of factoring, solving, and so important things to know that everybody should be able to do when they are about to take an Algebra 2 trig, or it's not Algebra 2 trig anymore, but an Algebra 2 Common Core Regents exam. All right, that's it for sample 7. See